morning. Welcome back to Open Med School. In the last session, we have discussed about the resting membrane potential. Today, we will be discussing on the Nernst equation and recap of resting membrane potential. So, what is meant by resting membrane potential? We all know that the living tissue are made up of cells, and cells have a positive charge outside. There is positive charge outside, and inside of the membrane is negative. And when you record it, and when the cell is in resting, it is called the resting membrane potential. There are two determinants for the resting membrane potential. One is the chemical gradient and second is the electrical gradient. So there are two mechanisms by which the resting membrane potential is maintained. One is the concentration and second is the electrical charge developed. So first is how the concentration gradient is made. So concentration gradient made because of the 3 sodium 2 potassium pump. This is an energy dependent thing. Utilizing ATP, ATP is converted to ADP and the energy is used to pump 3 sodium outside and 2 potassium is brought inside. So this is the picture of the biological membrane, and the membranes is semi-permeable. Some ions are freely moving, they are called the leaky channels, and some are actively transported. This sodium potassium pump is an active pump requiring energy. And because of the pumping of sodium, 3 sodium is outside and the 2 potassium is brought inside. Finally, what happens? Potassium concentrates inside the cell and the sodium concentrates outside the cell. So differing concentration of ions inside and outside the cell. So inside the cell it is potassium and outside it is sodium. So this is what is called, what I have said, the membrane potential is dependent on, one is the chemical gradient or concentration gradient. Now we come to the electrical gradient. We know that, so the potassium is more in the inside the cell, and potassium is always combined with an anion. The anion inside the cell is proteins, and the membrane is semi-permeable, and so what happens? The potassium will move against the concentration gradient outside. So as the intracellular potassium is around 140 milliequivalents and outside is only 4 milliequivalents, potassium moves against the concentration. This is the concentration gradient. The problem is the anions cannot move. So when the potassium moves, what happens? There will be accumulation of negativity inside the cell. So the inside the cell becomes more and more negative. Hope this point is clear. Potassium is moving outside, but the anions cannot move. So once the potassium is leaking outside, the charge inside the cell becomes negative. Now we can see that the potassium is accumulating or potassium is being pumped out. So they are positively charged. So as time goes on, the negativity inside increases and potassium will try to get inside. Potassium is positively charged and the inside is negative, so potassium will try to get inside. So this is the electrical gradient. Hope this point is clear. So there are two gradients that are occurring. One is the concentration gradient and second is the electrical gradient. And remember, the membrane potential is maintained due to the leaky potassium channels. As potassium leaves, the anions are left inside and that gives the inside more negative. So you can remember that the resting membrane potential, that is a membrane potential, is due to potassium. That is one point you should keep in mind. That is, a potassium is the determinant. if you look into the negativity, the resting membrane potential is approximately 70 to 90. So, this is the resting membrane potential. This is approximately 72 minus 72 minus 90 compared to outside. So, what is the contribution by the sodium potassium pump? So, when the sodium is pumped out and potassium inside, there is only small amount of change occurring in the negativity. So, this is the cell, 3 sodium goes outside and 2 potassium comes inside. So, what happens? More positive charges are gone outside. So, a minor change in the approximately 5% of the total negativity is contributed by this sodium potassium pump. The maximum, the majority is due to the leaky potassium channels. So, the potassium channels leaking makes the membrane potential approximately minus 90. At that time, what happens? There is a leaky sodium channels. So, here the concentration of the sodium outside is more. So, what will happen? The sodium will try to get inside. But the thing that you should remember is that compared to the leaky potassium channels, the permeability of sodium is less, or you can say the potassium channels are more permeable, approximately 30 or 75 times more faster than the sodium channel. So, only a minor contribution, that is as the sodium enters, what will happen? Sodium ions are positively charged. So, once it enters due to the leaky sodium channel, what will happen? The inside becomes more positive. So, that is only a small quantity, and from minus 90 it becomes minus 70. So, this is the maintenance of resting membrane potential. So, in short, resting membrane potential is produced due to differing concentration of sodium and potassium. These are the major ions. The causative reason, the first thing is a sodium potassium pump that pumps 3 sodium outside and 2 potassium inside, that produces a minor reduction in the voltage. Then comes the leaky potassium channel. Once the potassium is accumulating inside, potassium will try to go out through the leaky potassium channel, which is always open, and it is much faster than the sodium channel. So, that is how the membrane potential. So, this membrane potential at the resting state is minus 70 to 90, and this is called the resting membrane potential. Hope this point is clear. So, in the preceding few minutes, we have discussed about the resting membrane potential, the contribution by the sodium pump, and the leaky potassium channels. Basically, the membrane potential depends upon the concentration gradient, and second is the selective permeability of the membrane to various ions. The major ions are sodium and potassium, and that is why we are discussing about it, but some contribution by calcium and other ions are also there. Hope this was useful to you. We will come with what is equilibrium potential and how to calculate it by using the Nernst equation in the next session. Stay tuned.